Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit, zoals altijd, met...
Jan Stomphorst, een solution architect, ACC ICT.
Ja.
En ik moet het even snel doen.
Ja. Nee, helemaal prima. Zo, zitten we weer.
En
nog steeds.
met een lang verwachte gast. En die hebben echt al...
December, hè, de Dutch Cloud Native Day kwamen we...
Hebben we zijn talk gezien en toen hadden we zoiets van, deze moeten we hebben.
Ja, hij
Deze
heeft ons niet
gewoon-
omgekocht met chocola of zo.
Nee. We kregen geen bergen chocola, maar deze moesten we hebben. Dus,
Ja, precies.
En toevallig is die hier ook op dat mooie KubeCon.
Ja, op een
Dus,
mooie KubeCon. Nou, so I will switch to English and I would like to introduce Nicolas Fränkel. I hope I didn't butcher your last name because the German pronunciation
The
is...
last name is perfectly fine because I was born in France. This is a German last name, spoken mostly in English. So if you really want to be nice with me, the regular first name is Nicolas.
Nicolas, okay.
The last name would be Fränkel. I don't care anymore.
You've heard them all.
Yeah, I don't know how to pronounce my last name anymore.
Okay. You're a developer advocate at Loft Labs.
Correct.
And we met you at the Dutch Cloud Native Day.
That's true.
So can you please introduce
Amsterdam.
yourself in Amsterdam? Yeah. Can you please introduce yourself to the listeners who don't know you yet?
Ik ben Nicolas Fränkel. I work as a developer advocate at Loft Labs. I've been working in IT now for more than 20 years. The first part of my career was in regular projects in different positions as developer, team lead, architect, solution architect. And 6 years ago, perhaps 7, I switched to developer advocacy because I did a lot of conference talks. I have a blog since perhaps 15 years. And I say, perhaps I can leverage that aspect of what I'm doing.
Okay. And what got you interested in the IT? How did you get started? What was the little boy Nico
That's
doing?
very funny. So when I was a child, I got exposed like everybody to computers and stuff, but we didn't have so much money. So basically nothing happened. And then after high school, I didn't know what to do. So I studied different things. I studied physics. I have a master's degree in architecture, like the real one.
Okay.
I have a master's degree in civil engineering as well. But in the architecture school, we had 3D generation, but not like 3ds Max. But with like scene description in code.
Oh, okay.
And I fell in love. It was really amazing. I read all the documentation. I stayed a long time in the computer room. I became the go-to guy for my colleagues. And I said, I want to do that. And in France, it's very specific because in all other countries in the world, you go to the university, you can do whatever you want. In France, you go to engineering school, you can do whatever you want because of Napoleon and the Polytechnic school. So in France, anybody can go to university as long as you have your high school diploma. Mm-hmm. But in order to go to an engineering school, you need to have additional concourses or exams or whatever. And so I found a way to go to engineering school so that finally I could be a developer.
Okay, cool. At the Dutch Cloud Native Day, you had a talk about OpenTelemetry that got us interested to have this conversation. Can you take us back to December and tell the listeners what you talked about?
So the thing is, it was not about OpenTelemetry in general. It was about OpenTelemetry tracing. Most of the time, observability is described by 3 pillars: metrics, logging, and tracing. Metrics, everybody does it, hopefully. Logging, there are a couple of issues, but mostly, like most companies do it as well. Tracing, not many do. And in a distributed world, you want to understand how the flow of one business request flows through your components. And comes OpenTelemetry that allows you to track this flow.
Okay.
And how does that work then? Because OpenTelemetry does this, but how does OpenTelemetry track the flow?
That's a very good question. So you have two main concepts: the concept of a trace, which is a business request, and the concept of a span, that is something that happens in a component. Basically, if you would do it by hand, you would create through the API a span in your favorite programming language, and a lot of programming language already have OpenTelemetry support, meaning there is an API for that in your favorite one: JavaScript, Python, Java, .NET, whatever, Go, Rust. So you would create a span, you would do something, and then you would end the span, and then the span would be sent to your OpenTelemetry Tracing backend. In the demo, I'm using Jaeger. But anything that is able to receive OpenTelemetry traces would be fair game. Of course, this is very boring and it is expensive to write. So OpenTelemetry also provides you integration with many frameworks so that the spans, they are automatically created by default and sent when something happens. Of course, afterwards you can customize it, which I've demoed. So in OpenTelemetry Tracing works with a HTTP header that gets propagated throughout the different HTTP calls. So one of the problems that I've been asked at the beginning when I did this talk is, how does it work without HTTP, like with a message queue or with a Kafka queue?
Yep.
And in the demo, I've shown that you can use the API instead of propagating HTTP header to propagate it as metadata in your message queue and to recreate the context on the other side. So it works exactly the same way. It's just like some metadata that you add, and then you can recreate it easily.
So if I correct me if I'm wrong, you can use an header with metadata for your HTTP request, and if you do a Kafka request, you add something to the request.
That's even better. Like by default, most languages, most libraries, most framework, they do that for you, right? Well, you use, for example, on Java, use the Java agent. It will do that for you. So if you are a developer, you don't even know that there is OpenTelemetry running in your production environment because you don't have it in your dependency. It's a runtime concern where your ops or DevOps or however you want to call them, they just add the necessary runtime agents to change how the code behaves. Now, because it's through HTTP, if you don't have HTTP, you need to do it manually. Then the developer needs to add the correct libraries, to have the API, and to add them to the metadata if you are using a message queue.
So it's easy to start. Just add OpenTelemetry, and you can do that as an ops guy. But if you want to dig further, like in the Kafka things, the developer has to build it in.
Yeah, well, it's a bit more complex. Basically, you have two cases as a developer. Either you have a runtime, like the JVM, like Python, and then you can change the code that is running at runtime through, for example, a JVM agent. That is easy. The ops guy do the stuff during runtime. You don't need to care. Or you don't have a runtime. You are using Go. You are using Rust. Then you need to care about it. You need to depend on the libraries so you can do the things yourself. Now, if you are using a runtime, by default, you will have traces, but you can actually add the same libraries as if you didn't have a runtime to customize the result that you want. For example, by default, I've been using the agent in V1 on the JVM and the agent on V2. The agent on V1 tried to do a lot of detail by itself. And then if you wanted to remove traces, you had to customize what you wanted to have. The V2 has changed completely to the opposite. By default, there is one single span per component, I think. And then if you want to have more spans inside to see what's happening really inside the component, then you add annotations.
Okay, cool. And you said the outcome you will send that to Jaeger. Is that?
I said any OpenTelemetry trace compliant stuff, and I said in my demo I'm using Jaeger.
Okay. My question is, what are the alternatives to Jaeger?
Jaeger and Zipkin are the oldest one. You can have an intermediary OpenTelemetry collector if you want to do further customization, aggregation, whatever. And the Grafana stack, it's called Tempo.
And what's the best one?
I have no clue.
Oh,
That will be, I'm very straightforward. I'm not a production guy. So in my demo, I'm using Jaeger. And the reason for that is I need to use a single Docker image for that, which makes the demo very simple. At the moment, I'm writing another demo, which is not only about traces, it's about the full observability. So metrics, log, and traces using a Grafana stack. I'm using, at the moment, I've done the Mimir side, so the metric side, and I will be implementing the other one. From what I see from, again, I've been a developer, the Jaeger stuff is easy to set up. The other ones are really meant for production usage. And so basically, the Mimir side, for example, it requires you to have at least 2 pods of this stuff. And so it's really meant to have to be reliable and to be to avoid failure in any case.
okay. So, Grafana Tempo.
In your case, probably.
Yeah. I only run production stuff.
The good thing also with the Grafana stack is that with correlation ID, you can go from the log to the metrics, to the traces, and it's all correlated. So that's also what I intend to show in the demo.
Oh, that's awesome. Yeah, that was I was searching for. Because if you have logs of that event and you've got the Jaeger of the OpenTelemetry timing, not the Jaeger one, but this the Grafana Tempo, and then you've got everything together.
Yeah, that's an advantage. Also, but with logs, it can be, I mean, if you have enough data in your span, because you can add additional metadata in your span, what are the needs for logs anymore? I'm not sure, but I've read that question and I'm wondering about it.
Error messages? Errors?
Yeah, you can, in the trace, you also have the errors.
On the trace, you also have the errors.
Yeah. Like sometimes one of my component is not ready, and it tells you, "Oh, I have this exception." So depending what component you have, the Java component, for example, shows the stack trace. So I'm not an ops guy, so I can't tell you for sure. But I think that the question is interesting. Like, if we have really detailed traces, do we need logs anymore?
Yeah, that's a good question.
I know. I don't have the answer, though.
But we have to.
We have to think about that one. We'll find out.
Let's think about it, and maybe some of our listeners have an idea.
Yeah.
But it might depend, like in many cases in IT, on your own context. Some people will say, okay, in my context, I can do without logs. In some others, they will say, no, I will still need to keep my logs.
Also maybe the old-fashioned guys would think, no, don't touch my log files.
Yeah, but the biggest problem is from my opinion, OpenTelemetry and logging and is producing so much overhead. So I'm running my application. I've got OpenTelemetry. I've got log aggregation. I've got all those things running around that. So I'm producing more data on the application than the application itself.
Well, you have sampling. You should probably use sampling anyway.
Sampling?
Yeah. So basically, you have 1 million requests. You don't want to produce 1 million traces. It would be too much, as you mentioned. So probably you have sampling. You will say, okay, I will randomly choose 1%. And in general, this is not a fixed percentage. You will say at the beginning, for example, you would say, oh, I will keep 10% just to be sure. And once the system is more stable, you can decrease that percentage. And then you are introducing a new component in your architecture, you will increase it again. That's basic sampling, and OpenTelemetry knows how to do it. This is just basics. What you can do also is to have post samples, which is even better. Like you keep like a window of 10,000 requests, and somehow through AI, you detect those are outliers because those are the traces that you want to keep because you want to analyze them. The rest, okay, they are normal. I didn't work with them. I don't know which tool is doing it at the moment, but yeah, if you are interested in the subject, yeah, it's very interesting, I believe.
But still, you produce all the traces. That gives a bit of a workload. And it gives some storage because you have to remember those 10,000 or 20,000 and then you've got AI between there.
Oh, that's post sampling. So in post sampling, you will take a window, but you take 10,000, or if you don't have enough, you can say I just keep 1,000, and it's a window. You keep 1,000, and then you reduce it to 2 or 3, and then you take the next 10,000.
Still. And do you know if the AI between there is that small?
I have no. As I mentioned, I know about the concepts. I didn't dig into the tool yet. I don't know which library, which framework, which component.
I'm interested.
Yeah, me too.
Hold that thought. Maybe on the floor here we find somebody who has that post-sampling. Write it down.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Managed Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
Besides OpenTelemetry, you have the shirt you're wearing also mentions vCluster.
Yeah.
As the shirt doesn't mention it, it's on the shirt.
That's correct.
Can you tell us about vCluster?
Sure.
What it does?
So vCluster is by Loft Labs, by my company, and vCluster, as the name a bit implies, we are doing virtual clusters. So you have one host cluster, and we are creating a virtual cluster inside. It's a very technical brick, and you can do a lot of things with it. For example, you can imagine you are doing a pull request. You want to test the pull request in your target environment. You are targeting Kubernetes. Most people would spin on a new cluster, which so I've done the experiment with GKE. It takes about 5 to 7 minutes for a small cluster. Okay, it's not that much. If you do that 20 times, 2,000 times a day, it adds. And 5 to 7 minutes means that the engineer either is taking a long break or is starting to do something else. Then the PF fails, and they do context switching again. What you would do is you have a big host cluster on GKE or on EKS or Azure, I don't care. And then instead of creating the cluster, it's already created, you create a virtual cluster. Why do you need to create a virtual cluster? Why don't you just send the PR to the big cluster? Well, for isolation. Because if you you schedule everything on your host cluster, then you might run into issues. For example, I want to change the CRD version, and then everybody is impacted. So you want to have isolation, but speed also.
Right.
So you create the virtual cluster. It takes less than 1 minute. And now you have, not instant feedback, but very fast feedback. And you keep the host cluster running, and you only pay the cost for the control plane, which is up all the time. And for the small cluster, I think it was $80 per month, which is more than acceptable for any regular company.
Okay. I see you're thinking.
Yeah. I've got a few questions. You said,
I'm afraid.
yeah, of course. You're triggering me on $80 a month on
The control plane.
on only on the control plane.
That's the point. Yeah.
So we've got one big cluster.
Yes.
And that's the $80 a month on.
The control plane, what I've seen, what I remember is $80 a month.
Okay, and then we build a vCluster in there, and then the costs are going up.
Of course, but only for the duration of the PR, because at the end, on the GitHub workflow, the last step is you remove the virtual cluster.
Yeah.
So basically, your workload is only costing you for what the PR lifetime and not more. So you've got the speed, you've got the cost effectiveness, and you've got the isolation. And of course, there is a tension between all three, but it's for most companies, it would be a good compromise.
What does the separation from the vClusters? You spin it up. How does that work? I'm just thinking
So
you should start up a VM and start everything in there,
so basically, there are a couple of CRDs. It's available as a Helm chart or the CLI. You install it in a namespace. It creates those objects inside. It creates a Kubernetes cluster inside the Kubernetes cluster. So this cluster is a certified Kubernetes distribution. You have all APIs that you might want.
Okay.
And then you have a kube proxy file. You can use it, and then you connect to the vCluster. And inside the vCluster, you only see the vCluster.
Right. Okay.
And of course, sometimes you need to communicate with the outside world. So there are ways to sync services or CRDs.
Yeah.
Services, open source version, CRDs, pro version.
Yeah,
so
I asked because I remember a story from a while back that they also had that isolation. But what they did is build like a VM environment. And that was confidential.
That's the thing. In this multi-tenancy isolation world, it's a whole continuum. That you start with namespaces, and for some time it might work very well until you realize if you have like 20 teams using the same host cluster, every team needs to have specific permission, and some teams need to have more permission than others, and it starts to be a mess from an organizational point of view and operational point of view. And then one team needs to upgrade the CRDs, and then the other team can't do that. Because namespaces are very good, but the CRDs, they are not namespace, they are cluster scoped.
Yeah.
So it's a mess. And on the other side, you have dedicated clusters. And there is a whole continuum in between. So I won't cite any competitors because my boss would be very unhappy about that. But of course we have. And all of us, we have different strengths and weaknesses depending on your context. You might want to look into one of the other. I think vCluster stands at the middle. It's not perfect isolation, but it's very fast to spin on. And again, as I mentioned, once you have this technical brick, there are multiple use cases. For example, you could have one cluster for production and one cluster for all the rest. And then you could have one virtual cluster per team and per environment, because that's a big issue when you are using Kubernetes. What's the optimal size of your cluster? What's the optimal topology? Is it one cluster per environment, one cluster per team, one cluster? And this is a day zero question that you need to answer. And if you choose the wrong one, and the wrong one depends on your organization, then you need to roll back everything, and it's a mess. It's super expensive, it's complex. So this allows you to answer this question and be wrong and change the topology inside the big cluster because it's just a virtual cluster.
It's just a virtual cluster, right? Yeah.
I see people.
The radars
thinking,
are moving.
That's good. I love it. I love it. I'm just asking questions and offering people to answer on their own because I believe like engineers are smart and they can understand whether a solution can actually is relevant to their context or not. I'm not trying to convince you to use vCluster. I'm
thinking about when is virtual cluster a good solution. You said when you have to change your CRDs, CNI,
Every cluster-wide problem, namespace can solve them.
But if you just develop an application, vCluster is not a good solution.
It depends. If you are developing an application and somehow you need to test it in your own cluster, like in your own cluster, you could have a local cluster, of course, or you could have a remote cluster. Do you want every team member to have a remote cluster? It depends. And again, we go back to how are you organized? Perhaps it's better to have one huge Kubernetes cluster, remote, and then everybody has a virtual cluster. And then the team has a virtual cluster. And then there is a virtual cluster per environment, and they are of different size. The good thing is, in this case, every virtual cluster, the owner can have full permissions.
Yeah.
And you don't need to have this operational complexity saying, this team, they need to have more permission than this other team on this environment, because it really becomes a mess very easily. I mean, once you start to scale, it's crazy.
And bigger clusters are always better.
Sorry again?
Bigger clusters are better. Now they have less overhead.
Beer clusters, like beer?
Bigger, yeah.
Bigger cluster. Yeah, sorry, I heard beer. I was wondering,
beer.
Is it because it's Dutch? Is triggering me with beer?
I like beer.
Yeah, I know. So recently I wrote a piece about one giant Kubernetes cluster for everything. And of course, some people were not happy, which of course was the idea. But it could be a thing. And it's not, in general, it's not one giant cluster. It's one cluster for production and one cluster for all the rest.
Mm-hmm.
Or you could have smaller cluster, perhaps one per environment, and then virtual cluster inside. Again, the idea is just to make people think about what's your use cases, how do you want to organize yourself, and how vCluster can adapt its flexibility to your needs. Yeah. Because it's all about flexibility.
Yeah, it's suitable for production, right? vCluster.
Yes, it's also suitable for production. But to be honest, you need to do different things. For example, by default, we are spinning off its key 3S, and the configuration is stored in this SQL store that I don't remember the name of, the one that is local. In that case, you need to switch to etcd to have a regular etcd, so you can have backup and restore.
Yeah,
so
okay.
It's a bit more effort. So you can do it, but perhaps it's not what you want. But it's like a lot of solutions. You might start by doing this PR stuff, and then it works very well, and you get the solution, and you want to expand how to use it up until production.
Okay, yeah.
So you can use it from simple things to production-like things. It's up to you.
Yeah, well, I can see managed providers offering some kind of thing. They have a big cluster, and all the customers just get a virtual cluster.
For example, multi-tenancy is one very good usage of virtual cluster. You want to provide customers with some services. You want to host them all on the same real cluster.
Yeah.
For operational complexity, one single cluster, and for security purposes, underneath you have virtual cluster. This is one of our use cases.
Yeah, because what you hear a lot about is Kubernetes on Metal, and Kubernetes with KubeVirt, of Kubernetes, and then Kubernetes with KubeVirt, and running there.
Kubernetes and Kubernetes.
Yeah, that's the thing.
You've got also kind clusters, and you've got all sorts of.
But I think this is what I've picked up so far. It's a nice addition in that line.
Yeah. I know we have an integration with KubeVirt. I didn't play with it. I can't tell you anything. But if you are using KubeVirt and you still have issues with it, you want more flexibility, have a look. vCluster.com.
And you said,
plug away.
You said, how do you expose your virtual cluster then? You said something about CRDs, but how do you expose your virtual cluster to the network?
That's well, from a very high point of view, like any other cluster, Basically, what I did in the PR, I created the virtual cluster. One of my service was of type load balancer. Google gave me an IP.
Oh yeah.
Oh, yeah. Because again, a virtual cluster is Kubernetes compliant. It's one of a regular distribution. What you can do, if you don't want to expose it, you can sync objects between the hosts and the virtual cluster. Okay. For example, you can sync services. What I did in my demo in Amsterdam was I had one virtual cluster. I was using an OpenTelemetry collector, and I had the Jaeger on the host cluster. And Jaeger exposed the service to the host cluster, and I synchronized the host service from the host cluster inside the virtual cluster.
Okay.
So it's as isolated as you want, but by default it's fully isolated, and then you say, oh, I need to sync this. With the Pro version, you can also sync CRDs.
Okay. And what if...
What if?
The what if?
Let me think about this super edge case.
Yeah, of course. What if I wanted to encrypt my network traffic on the virtual cluster?
With which tool? Because
I
I
just
suck at networking. So let me be clear. I need to have more information, or I will say I don't know.
Okay. Now, I'm not sure. I'm not sure what tooling, but there's a case that we've got a multi-tenant cluster, and I don't want to
The communication from one cluster to another cluster.
Yeah, I've got two customers, and they can't interfere. And,
that's the point.
And I want to have that traffic in that cluster encrypted because it's sensitive information.
Yeah, I don't know which tool, but basically you would do as any tool inside a regular cluster. If you have a tool in mind, you can use it inside a virtual cluster.
If I run Cilium with BGP with eBPF.
That the problem of eBPF depends on the platform you are running. So I can't say, for example, it won't run on my machine because I'm using a Mac. But as long as you have a Linux kernel, then it probably work. I should probably try it, but on a theoretical point of view, it should work.
Okay.
Something to
no.
I won't go further. Again, this is I suck
no.
at networking, so I won't.
But the question is valid, because if you have a large cluster and you don't want the communications from the vClusters to intervene, or that somebody breaks out of their cluster.
But that's the thing. When you are inside the vCluster, you only see the vCluster. That's the thing. Again, it's fully isolated by default, unless you say, "Oh, I want to expose a service from the host to the virtual cluster," or the other way around.
Is the networking then also isolated? It's the same question but different.
No, you really want to put me in a bad position, as I have said 2 times that I suck at networking.
Yeah. But is the virtual cluster using the same addresses space as the other virtual cluster? So they can't break out in any way.
What you would need to do if you want 2 virtual clusters by default to communicate is you would need to install an Nginx, for example, an ingress controller in each of them. And then you would, inside the virtual cluster, then be able to dispatch. Okay. So you would go outside from one virtual cluster and then would be dispatched to the other. But again, it means that both virtual clusters
are fully isolated.
Yeah, that they need to agree that, okay, I will expose this controller and blah, blah, blah. So again, by default, it's isolated. If you have use cases that you want to break out, either you use this direct service like synchronization, and you would need to do that because the ingress controller from, let's say, a virtual cluster B would be exposed to the hosts.
Yeah.
And then you would also expose it from the host to the other virtual cluster, and then you would be able to do that. But it requires like to synchronization. And this synchronization is done when you create the virtual cluster.
It could also be useful to test if you want to test out a service mesh or something kind of. And I think it's like this is. I know we're going off rails maybe a little bit, but
I need to work on the subject. I never touched Istio, to be honest.
No. But it's just
Okay. Yeah.
okay. We leave the network part here.
So it's isolation, networking, deploying easily, fast. So everything is in a container. You set K3S is the standard.
Yeah, it's by default we deploy K3S Kubernetes.
And can we use another version?
Yes, but I never tried.
Okay.
Again, I started to work in November. So I don't know everything yet.
Okay. Is it also suitable for on-premise? Is it only for the hyperscalers?
I already had this question this morning. You can deploy a virtual cluster in any cluster. So it can be remote. It can be like on your laptop. It can be on-premise. It can be anything.
Okay.
For example, I did want to try with WebAssembly workload on Kubernetes.
There you go.
We've got a podcast about that.
That's one of my current talk offering actually, and I don't like to play too much in the cloud, especially for demos because it's always unreliable. So what I did is I used one Minikube. And inside the Minikube, I could actually use the runtime that I wanted. And every one of those images, they run in the specific vCluster.
Okay, cool.
With an
That's
Nginx
fun.
controller.
Yeah. Oh, that nice one. Yeah. So, Nicolas. Not to hold you any... Nicolas. I'm sorry, yeah.
Don't worry.
I don't know why did I got a Nicolas. Is that on your LinkedIn or is that...
No, that's the problem. That's the French first name, so I have an S. But because we want to fool foreigners in French, we don't pronounce most of the time the last consonants.
Okay. Nicolas. If I would put a crystal ball here on the table, what would you like to see for the future of Kubernetes? And they say, everything in vCluster, but that will be too easy.
Honestly, I think that if you are... So I started my journey in Kubernetes 6 years ago. I was working for a Swiss cloud provider. I didn't touch it for like four years. It's a huge topic. It's a changing topic. It's a complex topic. I would really, really love that it's easier to get into it. Like, it can take years until you really are proficient in one area, not mentioning all the areas. The ecosystem is huge. You have new components popping up like every month. Simplification would be a lot better. For example, at some point, I got interested in how you would get traffic into your Kubernetes cluster. So first, there was not ports. Then they came with ingress controller. Now you have the gateway API with different levels of implementation depending. And there are still issues with the gateway API. So at some point, they will probably add another object. If you are coming into what should I use? You have no clue.
Well,
So-
Ingress is proven.
But that's the thing. Ingress is proven, but it's lacking in many different areas.
No, Ingress, we just heard, Ingress is not maintained anymore. So
Yeah, it's not maintained
But it's
anymore.
stable.
But it's
it's stable
it's
for the
proven
moment.
in the past few years.
But for example, one stupid stuff is Ingress is very nice, but the specification doesn't allow you to remove the prefix.
Yeah.
So you need to use one of the implementation dependent way to do that, mostly with annotation, which depends on which implementation you are using. So what's the point of a specification if you in the end need to understand the implementation? So the gateway API was meant to solve that. But again, they didn't go completely to the end of it. So that's why my point. They will probably at some point event one things. That's really hard. And at least they could deprecate the node port. They could deprecate a lot of stuff. Like in every language or technology, at some point they deprecate stuff.
Now everything depends still on node ports.
okay, let's say they would need to deprecate ingress controller at some point. Especially if it's not maintained anymore. But you see my point? This like it's like archaeology. You are facing a lot of different ways to do the same thing, and as a beginner, it's very hard.
Yeah,
so
it's difficult.
I don't know if it's a crystal ball, but I think that making things easier, like the beginner's path, should be like one of the really things that should be, I shouldn't say enforced, but worked on.
Okay.
Well, thank you. If it's simpler, we don't have a podcast.
We will find topics.
Something to think about.
Bedankt.
Yeah, thank you very much.
Yeah,
Thanks a
Nicolas,
lot.
thank you very much. And talk to you again in the future.
Hopefully.
Okay. Yeah. Okay. Bye.
Bye-bye.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.